Imagine you're looking at this handwritten digit. It's clearly a 3. But how does a computer, a machine that only understands numbers, see this image and arrive at the same conclusion? This isn't just a fun puzzle. The ability for computers to interpret messy, real-world data, like handwritten digits, or complex financial reports, or even human speech, is the bedrock of the AI revolution. And understanding how this seemingly magical process works is key to understanding the incredible growth and Q2 earnings we're seeing from leading AI companies. They're not just selling AI, they're selling sophisticated systems built on these fundamental principles. So, let's strip away the hype and dive deep into the core mechanism. How does a computer recognize this NLT, span style equals color blue, and GT, handwritten digit and LT/span and GT? In our previous videos, we've touched on how AI learns from data and even the intricate dance of the attention mechanism. But today, we're going back to basics, to the very first step. How does raw input become a meaningful decision? This foundational understanding isn't just academic. It's the engine behind the impressive financial results of companies leveraging AI in healthcare, finance, and countless other sectors. The same principles that let us recognize a 3 are scaled up to power complex predictive models and intelligent automation. Let's start with what a computer actually sees when it looks at our NLT, span style equals color blue, and GT, handwritten 3 and LT/span and GT. It doesn't see a graceful curve, it sees a grid of tiny squares, or NLT, span style equals color yellow, and GT, pixels and LT/span and GT. Each of these NLT, span style equals color yellow, and GT, pixels and LT/span and GT, is just a number. If the pixel is dark, it might be a high number, like 1. If it's light, it's a low number, like 0. Or, more commonly, a value between 0 and 1 representing shades of gray. So, our NLT, span style equals color blue, and GT, image and LT/span and GT, is transformed into a long list of numbers. If our image is 28 by 28 pixels, that's 784 numbers. This list of numbers is our NLT, span style equals color blue, and GT, input vector and LT/span and GT. Now, how do we get from this list of numbers to the decision that it's a 3? We need something to process these numbers, to make sense of them. Imagine a tiny, digital neuron. This neuron's job is to look at all these NLT, span style equals color blue, and GT, input numbers and LT/span and GT, and decide if